And there you go. All right, let's go ahead and flip the page. We're just going to continue practicing this by gathering our data and using our data to group it. So example one has a table that has 80 students in an IB class that an IB class achieved out of a total of 100 marks. So we're going to develop a relative frequency table and a cumulative and relative cumulative frequency table of the data. So we need to group our totals into a certain range. What I did here is I looked at that our lowest score was a 41. So our minimum here of our score is 41. The max score that we got is 98. So if I wanted to look at the range of my values that I get, I would subtract 98 and 41. By subtracting those out, I get 57 numbers. I'm covering a range of 57 numbers in these intervals. Again, we're trying to be somewhere between 5 and 15. Notice I did 1, 2, 3, 4, 5, 6 here. So that's kind of giving you a hint already that I wanted to go with 6. If you do 57 divided by 6, you get 9.5. So I was like, okay, well then what if we did intervals of 10? Trying to go by intervals of like 2 or 5 or 10 or 20 or 50 or 100, depending on the range of the values that you're looking at. Trying to do intervals that are kind of nice like that, 2, 5, 10, 20, right? They're kind of like intervals that you would use when you're graphing. And that's the same idea as we want kind of nice intervals. So I was like, I think 10 is going to be a nice range. We could do between 40, 50, 50, 60, and so on. And that's a way we tend to group grades anyway, so that we're going to follow that. So how we talk about the range here is we want to be between 40 and 50% of the score, which means then our next range is going to be between 50 and 60, 60 and 70, 70 and 80, 80 and 90, 90 and 100. And we've got our X down the middle of all of them. Notice now, unlike the page before, we now have 50 occurring twice. We cannot include it in both of those ranges, right? You can't include 50 in this one and in this one, because what if you had 50 exactly? Where would it go? We typically include the top number in the next range. So we would include 40 in this range, but not include 50. Which means 50 would be within this range. We are including 50 in this range. Think about grades. 50 would still be an F, right? Well, here, let's talk about this. 80 would be a B, but 90 would be an A. So you've moved up to the next interval. So grades follow this interval grouped data distribution just the same way. So 60 is included, 70 is not. 70 is included, 80 is not, and so on. So now we need to go through and find the number of students and the frequency of these students. So go ahead and go through and count how many students are between all of these ranges. All right, so this is our frequency of each of these scores within our students. If we wanted to know our total of students, we would just add these guys all up, or you can count the area of the boxes that we have, or I could just tell you that the total is 80. We are now going to take this and talk about our relative frequency. Remember that our relative frequency is the individual frequency divided by the total number of students that were studied. So if the total number is 80, then the relative frequency here would be 15 divided by 80. What percentage of students are represented in this category? So I'm going to divide those out. I'm going to get a decimal, which is 0.1875. In other words, 18.75 students were between 40 and 50% on this test. Go ahead and fill out the rest of this relative frequency. All right, so here's our relative frequency, pretty straightforward. We next want to do our cumulative frequency. And remember, our cumulative frequency is the running tally of the frequencies that we have. So we start off with 0, and then we add in 15 students. So we start off with 15, and then we say, okay, we add 18. Adding 18 to our total is 33. Adding another 18 is 51. Adding 11 is 62. Adding 12 is 74, and adding 6 is 80. And again, getting to that total. I remember when I was first learning this in a stats class, and I was like, why do we care about cumulative frequency? And it is very important because it's typically how you're presented data. I don't know if you remember taking the MAP test. I think you guys had maybe 1 year of the MAP test that the younger kids are doing. And they say like, oh, you're in the 90th percentile, right? So if you're in the 90th percentile, that means that out of a total of 100%, here is 90. We're talking about the full range of values of not 100%, because the top person, the best person who scored, didn't necessarily get 100%. But the 90th percentile means that you're within the top 10% of the scores that were available. Whereas if you're on the 50th percentile, you're in the top 50% of the scores that were scored. If you're in the 25th percentile, the 25th percentile means that you would be within the top 75 students. In other words, you're within the bottom 25 students. So that's kind of the idea of percentile, and that's where this comes from. If you do 74 divided by 80, or let's talk about the 25th percentile. So if I wanted to find the 25th percentile, I want to find out where is 25% of 80. So if I do 80 multiplied by 25%, in other words, 0.25, I get the number 20. So 20 falls at this interval, right? 15 is still too small, but the 20th student happens here. So the 20th student, because 25% of 80 equals 20, the 20th student is within this range, which means that the 25th percentile of the scores happened at between 50 and 60%. If we talk about your class midpoint that we talked about on the other side, if you remember with our Voronoi diagrams, how we took the nearest neighbor interpolation where we had our site, and in our site we were like, okay, well there's this one, or this cell, right? In our cell there's this one site that has data, whether it's rain, inches of rain that have fallen, or whether it's the amount of disease that's happening within that area. You use this one site to dictate or determine what is going on with the rest of the population in that cell. And it's kind of the same thing with this class midpoint. With this frequency, you can say about 10 clusters of grapes had 14 grapes on a bunch. right? So you're saying, okay, technically it's between 13 and 15, I'm gonna just say 14 as the point that decides what else is happening with the rest of those numbers. So I'll give you a different example if that didn't make sense. So in here, the class midpoint would be 45%, right? So we're saying 15 students scored about 45%. So when we're talking about our 25th percentile, the 20th student lies here. So you can say that the 25th percentile is at about 55%. So if you're within the 25th percentile, that means you got a 55% or lower. So that's kind of the idea of why we care about cumulative frequency. It's how data is presented. A lot of people care about it. I have a lot of students who come up and say, well, I'm in the 80th percentile and I want to be in the 90th percentile because I want to be in the top 10% of my class, right? If you're talking about a valedictorian or the top 5% of the students that are in your class who get a special mark of their grades, right? This is how you calculate it. You use cumulative frequency and use all of this frequency data. All right, relative cumulative frequency is when you take your cumulative frequency and make it relative. So I need to divide it by the total. So here it's still going to be 15 over 80. However, for my next guy, it's going to be 33 out of 80, which is 0.4125. And then we're going to keep on going on. So here you could say, well, 78% of the students scored 75 or lower, right? So now you're starting to group again. So this cumulative frequency is this idea of grouping students into like highs, lows, mediums, mids, mid-high, mid-low. That's kind of what we care about with cumulative frequency. If you remember box and whisker plots, this is when we're starting to build our way into box and whisker plots. If you don't worry, I'll teach you about it. So with that, moving forward, here is a frequency table. Here's a bunch of things that you have to know with a frequency table, and we're going to move on. If this did not make sense to you, we can spend time in class talking about it. Just make sure to bring it up and we can talk about it, and we'll do more examples.